often refers to a concept in animation and rigging, particularly in 3D modeling and character animation. Constraints are used to control the behavior of bones in specific ways, enabling more realistic or controlled animations. The more bones you have, the harder it becomes to animate, and without any constraints and controller, it is tedious. Combining what you have learned with constraints, bones, and IK or FK solutions, you can get a very pleasing animation process. You can still animate without them, but it becomes just harder. Constraints are very important in both the rigging and animation process. Typically, your 3D application will have several options for constraining. Constraints limit an object's position, rotation, and scale based off of the attributes of the parent object. For example, by taking two separate spheres, applying a parent constraint, and then deciding which is the parent and which is the child, you can select just one and the other will follow whatever the parent is doing. Setting up constraints is a vital step when creating control curves for the rig. Here are some types of bone constraints commonly used: IK, inverse kinematics constraints. These allow for natural movement of joints, especially in limbs, by setting end targets. For instance, moving a character's hand with an IK constraint automatically moves the elbow and shoulder, maintaining a natural bending motion. FK, forward kinematics constraints. This approach involves directly rotating individual bones, typically from the base to the tip, allowing for precise control over each bone, but requiring more manual manipulation. Position constraints. These constraints control the location of bones relative to a target, which can be useful in situations where a bone needs to follow a specific path or stay within a certain area. Rotation constraints. Rotation constraints limit the rotation of a bone, often to prevent unnatural joint movement or to mimic the limited flexibility of human joints. Scale constraints. These keep the scaling of bones consistent, useful when bones need to maintain proportional size relative to one another or the character's overall form. Parent/child constraints. These constraints make a bone's movement dependent on its parent, keeping them linked so that one affects the other. This hierarchical relationship is crucial for maintaining structure in complex rigs. Pole vector constraints. Used with IK systems, pole vector constraints guide the direction of joint bending, like knees or elbows, by setting a target point for the joint to point toward. Driven keys to speed up the animation process for the animators. A rigging artist can utilize driven keys when rigging a character. Driven keys allow you to use one control or object to drive multiple different objects and attributes. In the example above, we can use a driven key to control the fist position for the hand, with just one single control. A driven key contains two parts, the driver and the driven. The driver is the object in control of the animation. The driven is the objects and attributes that are being controlled by the driver. Let's reflect on what we have learned so far.